All right, ladies and gentlemen, here's the recording for section 11.1. And so in 11.1, we're dealing with sequences and summation notation. You'll find this content does show up in Calculus 3. There is some summation work in Calculus 3. Bear with me for a second. I'm just writing this down for you so you have the header. And so we are going to begin with example 1. And so in example 1, we are writing the terms of a sequence from a general term. And so in this example, they begin with a sub n is equal to 3n plus 4. Now, if they ever give you this question STEM, I would ask you to always begin by substituting, starting with 1, never 0. So you start with 1, then 2, up to whatever number term they ask you. So if they ask you to the 4th term, then you go to the 4th term. So in this example, actually the question STEM says, write the first 4 terms. So if I'm writing the first 4 terms, I begin with substituting in with 1. And so in this example, you would begin with a sub 1 is equal to 3 times 1 plus 4. A sub 2, which is 3 times 2 plus 4. A sub 3, which is equal to 3 times 3 plus 4. And the last one, a sub 4, a sub 4, which in this case would be 3 times 4 plus 4. And so our answers for these respectively would be 7, this would be 10, this would be 13, and this one would be 16. And that's the idea of this example. This is part A. There is a part B, it's the same thing. I'll just show it to you just for the sake of doing the entire example. So for part B, same difference. They ask you to substitute this in. We have negative 1 to the nth, and all of this is over to 3 to the nth, and then minus 1. We are writing the first 4 terms. And so we begin by substituting, starting with n is 1, n equals 2, n equals 3, n equals 4. And so very simply stated, this will become basically a sub 1 is equal to negative 1 to the 1 over 3 to the 1 minus 1, which simplifies to negative 1/2. We'll do the same thing with a sub 2, a sub 3, a sub 4. So I'll give you a few minutes to try and figure that out. And if you have questions, let me know. A sub 2 should result in 1 over 8 once you're done substituting. A sub 3 should be negative 1 over 26. And a sub 4 should be giving you 1 over 80. And so the first 4 terms of the sequence are, as you can see, negative 1/2, 1/8, negative 126, and then 1 over 80. Okay, I'll give you 2 to try in case you're interested in doing a try. We could do this either during class or while you're doing your notes. So they start with, in the try, they start with a sub n is equal to 2n plus 5. And for part B, they give you another one similar to the last one, where a sub n is equal to negative 1 to the nth. over 2 to the nth plus 1. All right, here comes example 2. Now in example 2, we have using the recursion formula, or using a recursion, okay, so they start you with the question stem that says find, again, the first 4 terms. They're just doing it to limit you so that you're not doing a very long question. They're just giving you 4 terms of the sequence in which a sub 1 is equal to 5, a sub n is equal to 3a to the n minus 1. Now that's a subscript, don't mistake that for a variable. And that is added to 2, and this is 4 values where n is greater than or equal to 2. So let's begin with the fact that they start you with a sub 1 is equal to 5. So we begin a sub 1 is 5. Now with a sub 2, remember we have 3 times, let me actually change the color so you can follow the sequence, where it's 3a sub 1 plus 2 is the answer. So that's what a recursive formula is, kind of like leapfrog. Have you ever played leapfrog, which is the frog, you're jumping over the person in front of you? So in this case, what we really have is 3 times 5 and then 3 times 5 plus 2, which will give us 17. So now we know that a sub 2 is 17. So when I do a sub 3 is going to equal 3 times a sub 2 and then plus 2. So if that's the case, then again, I know that I have in reality 3 times 17 and then obviously plus 2. And this results in 53 and so on. All right, and so that means that I know that a sub 3, which is 53, and so here's my a sub 4, and that's equal to 3 times a sub 4, I'm sorry, a sub 3 plus 2, and so my a sub 4 is going to be equivalent to 3 times 53 plus 2, which is equal to 161. And so those are the first 4 terms that are given to us in this recursion formula. All right, so I'll give you another try to do on your own. You can try this one. So the question stem for this one says find, again, the first 4 terms. You know what, I'm going to change it to 5. Let's get crazy. The first 5 terms of the sequence. In which a sub 1 is 3, and we have a sub n is equal to 2a sub n minus 1 plus 5 for all values where n is greater than or equal to 2. Okay, now keep in mind that if this is a sub 1, this notation here is saying, hey, go to the one before that. That's what that's telling you, by the way, in layman terms. Okay, I'll give you a few minutes to do that in class, or you could do this at home on your own leisure time. All right. So let's talk about factorial notation. I'm surprised how many people do not recognize or know factorial notation. And so that is the prime. So whenever you see something such as n prime, what this really indicates is that this is n times n minus 1 times n minus 2 times n minus 3 and so on. So you're always going, in this case, you're counting down the numbers. So if I have, say for example, I have 4 prime as a value, then this means that this is 4 times 3 times 2 times 1, right? And so this total would be obviously 24. Another little tidbit or well-known fact that you need to know is that 0 prime is actually equal to 1, which you would never think. How can 0 prime, anything times 0 should be 0, but no, it's just a fact that 0 prime is equal to 1. Given that information, the next question is very similar. It says in example 3, it says finding terms of a sequence involving factorials and then they're asking you as the question, basically you're going to write the first 4 terms. This is getting mundane with the 4 terms already. But this could be any set of numbers. Don't get stuck on 4 terms. They just happen to use the first 4 terms. Could be 5 terms, 6 terms, you know. And I'm just trying to keep it simple for you, so I'm going to stick to the script. So find the first 4 terms of the sequence. And this sequence is a sub n is equal to 2 to the nth power over n minus 1 factorial. So you're basically going to start with n is 1 in the substitution, then n is 2, n is 3, n is 4. And you're going to substitute it into the formula using the notation. A sub 1 is equal to 2 to the 1 over 1 minus 1 prime, which happens to give you 2. Remember, even though that's 0 prime is 1. If I have a sub 2, well, that's going to equal 2 to the 2nd power over 2 minus 1 prime, and that's going to give you 4. If I complete this with a sub 3, then this would be 2 to the 3rd power over 3 minus 1 prime, which is equal to 4. And then a sub 4 is going to be 2 to the 4th power over 4 minus 1 prime. And this is going to end up being 16 over 6, which is 8 over 3. And that's your sequence for this particular summation. Again, I'll give you a try. So I'm going to write it right next to this one. So they're going to ask you to find the next 4 terms. And then I'm just going to keep it simple and do a sub n equals 20 over n plus 1 prime. And just find the same, use the same directions as above. So you can do this in class with me, or we could just leave this for a little bit later. You can do it on your own time, depending on how quickly we're moving along. Here's example 4. We are evaluating fractions with factorials. Okay, so they want us to evaluate in this case. They're giving us, for part A, they're giving us 10 prime over 2 prime times 8 prime. So you can do this one of two ways. Now I'm going to show you the long way first, and then I'm going to show you the short way, which is very easy. So if I'm looking at this, I know that this is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And all of this is over 2 prime, which is 2 times 1, times 8 prime, which is basically 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So if you noticed, there is a repetition here, 8, 3, 2, 8, 7, 6, 5, 4, 3, 2, 1, and that is also repeated, so they cancel top to bottom. You can also reduce going this way. 2 goes into 10 5 times, and obviously you're left with 5 times 9 on the top over 1. And your final answer for this would be simply 45. Now, what I meant by the simple way is, you noticed how this is already 8, 7, 6, 5, 4, 3, 2, 1. It's basically 8 prime over 8 prime. So I could have just simply written this as 10 times 9 times 8 prime over the 2 prime times 8 prime. So I would have automatically just reduced or simplified that. And I would have also considered the fact that 2 prime will go into 10 prime at least 5 times. And then again, we're left with the same answer. Now this next one usually makes students a little nervous, but you need to go back to your notes and look at what I said to you earlier. So if you notice that this one starts with n plus 1 prime over n prime, and if I were to simplify this, this would simply be n plus 1, and then the following value would be n prime, obviously. All of this over n prime. So the n primes actually cancel each other out, and you're left with your final answer, which is n plus 1. So what I ask you to do is, I want you to stop and think for a moment, and we are going to do these two examples. Go back to here where I started talking to you about what factorial notation is. We're going down from the number down. In this case, I started you before the number, which is n plus 1, which precedes this number here. Okay? All right, so let's go back. I'm going to give you another example similar to this. And let's see how you do. So this is the one that concerns me. So let's do 2 checkpoints. So I'm going to give you a try. I think that you can do this one on your own. I'll give you a minute to solve for it in class. This one is 14 prime over 2 prime times 12 prime. All right, and this answer should result in 91 once you're done. So I'm not concerned about that one. It's this one I'm concerned about. The try 2, which is n prime over n minus 1 prime. And so I'd like for you to try that one and see how you how you reason. I'll give you a couple of seconds to look at that and see how you do. All right, and the answer to this one, as we complete it, should result in n. Okay, if you start with n prime, I want you to realize that if I'm doing n prime over n minus 1 prime, that this has to result in n. And as you reason through this question, I want you to think about the pattern. If I have, going back to this example here, if you have n prime, then this is really n times n minus 1, right? So I'm looking at the question simply as n prime for the top part, which means that this is n times n minus 1 at least, right? And this is divided by, the n prime is being divided by n minus 1 prime, which is at least going to be n minus 1. Canceling this out, leaving you just n. Okay? All right. So that one, it's just to think. It's a critical thinking question. It's did you connect with the main concept? All right. Next example is example 5. In example 5, we're talking about using summation notation. And so they're going to ask you to expand and evaluate the sum. We use this a lot in computer language in the business world. We use the summation notation quite extensively, so please listen to this example. So the first thing that I want you to note is that the top number is always where we stop. That's the summation notation. This is uppercase sigma. And this tells me the upper limit of our value. And then here, the integer I is equal to 1, which means that I start substituting in 1. So this is the equation they're giving us, which is I squared plus 1. What I would recommend you to do is to do this not on a calculator per se, but maybe use Excel, which is a good try. So when we do this notation, notice that I'm going to start with, in this case, I'm going to start with 1 squared plus 1, 2 squared plus 1, 3 squared plus 1, 4 squared plus 1, 5 squared plus 1, and 6 squared plus 1. And when you do the math for these, you'll notice that this gives you 2, this gives you 5, this gives you 10, this is 17, 26, and 37. And what I'm doing is I'm adding all of these up, and this equals 97. That's what summation notation does. And what I was suggesting to you is that maybe you learn how to use Excel. If you're not afraid, I could show you. And And you can actually program Excel to be the equivalent of this if you'd like. I'll show you right now. So and this is a little bit over the top. It's not something that's required of you per se for the course, but for life, it's good for you to know. So I'm going to pull up an Excel sheet. If you would do the same with me, that might be fun for you to try. And you'll see that you can do your homework very quickly and easily with this. And so let's open up an Excel sheet. And if you'll notice, the first thing I'm going to do is I'm going to set it up so that I have an answer cell. Since my integers are 1, 2, 3, 4, 5, 6, I'll write them here on the side. And this is going to equal this number raised to the second power plus 1. Okay, and that should give me my first answer. And now that I have a formula in here, I can literally just drag and drop this. So if you notice, it gave me all of the values that we calculated. And this is the summation auto sum. That's the summation notation. Notice that we get 97, and that's our answer. So this is how Excel could be used for these questions. It might help you, especially when you get to Calculus 3, because those questions are, I mean, they take you out to 50, and it's like crazy numbers. And yeah. So I just want to show you that one. You could play with that and make that your own little project if you wish on the side. It might be fun for you. And it's certainly a life skill that you'll need, because using Excel is, especially in accounting, very useful. All right, for part B, I have 7 as my finite number, and then I have k equal to 4. This value is negative 2 to the k minus 5. Okay. Now, the trick to this one is that you notice that it's not 1, like the ones we've started with, right? This is actually going to be basically starting with 4. So if I begin this example, this will be negative 2 to the 4th power, because that's my starting point, minus 5, plus, notice that I'm going to do negative 2 to the 5th, minus 5, plus, this is going to give me negative 2 to the 6th, minus 5, plus, and this is going to give me negative 2 to the 7th, minus 5. All right, and so as I do the numbers, I'm going to end up with, in this case, 11 plus negative 37. Let me do parentheses. Plus 59. And plus, and then negative 133. And the answer for this sequence should be negative 100. All right, so if you wish to try this one on Excel, we could certainly go ahead and do so. So let's take a peek. I'm just writing it down so we can follow it along. All right, and so one more time with Excel, and this will probably make your life easy. So now notice this one, and the reason I'm doing this one as well is because it starts with 4, 5, 6, 7. And so I need to start with the notation, which is basically parentheses, or no, excuse me, bracket. So this equals bracket. And then I have a negative 2 raised to this cell, and then all of that minus 5. You have to be careful in this case because sometimes Excel gets confused, and you may want to put parentheses. So I might actually do a double parentheses here, so I don't want it to do the -5. Right, and so that answer, let's see what we get. Okay, so it's not happy with that, so yeah. Got it. Let me take away the brackets. Maybe this doesn't like the brackets. And then play with that. What did we get, 11? All right, so now you drag and drop. I think our numbers are good. The -37, 59, yep. And we auto sum. And that's -100, which is your answer. Okay, so I just wanted to show you that one on Excel. This is the last one I'm going to show you, I promise. And then I'm going to ask you then to look at these next few. And let's see if these are try questions. You could try them for your own edification. Now, let me, actually, before I do this try, let me definitely do this one, because this part C one is going to be a little different. Notice this one has the summation ending at 5, starting at 1. However, your number is just a 3. So what do you do when you have that? There's no I next to the 3. Basically, when you have, think of it like positions. You have 1, 2, 3, 4, and 5. So this is 3 plus 3 plus 3 plus 3 plus 3. Final answer, 15. So for this one, there is no substitution. There is nothing of that sort. All right, I'm going to give you 3 to try. They're all different, so you could either use Excel or use your math skills. So there's your summation symbol. In this one, I is equal to 1. Here I do have substitution, so this is 2i squared. We'll do that one. The second one I want to give you is, again, this one ends at 5, starts at 3, and this formula is 2 to the k minus 3. And the last one I'm going to give you is 5, where this is summation of I equal to 1, and the value happens to be 4. The answers you should have, by the way, so you could check your work if you use Excel. I have 182, I have 47 for the answer, and for this one I have 20. All right. Now, there's one last example, and that is example 6. So let me finish with that one. All right, so you can go ahead and try that. If we have time, we'll do it in class. If we don't, you're just going to do it on your own. In example 6, they're simply asking us to write sums. So writing sums in summation notation. And so it says express each sum using summation notation. All right, and so I'll begin with part A. So they give you 1 cubed plus 2 cubed plus 3 cubed, ... It ends at 7 cubed. So when we express something like this in summation notation, you notice that it ends at 7, starts at 1, and there's obviously the value seems to be a value cubed. So this would be summation notation ending at 7, where I is equal to 1 as a start of I cubed. And that is your answer. This is how you actually reduce this to summation notation. All right. And so part B, they give you 1 plus 1 over 3 plus 1 over 9 plus 1 over 27 ... And then they have 1 over 3 to the nth minus 1. So this tells me that there is a formula involved. There is no, it's infinite. There's no end point. So in this case, again, we obviously start with 1, so I equals 1. We don't know the end. Notice that I use an n. They do give you the formulas, which makes your life very easy. All you got to do here is change this to 3 to the I minus 1. And that's it. So let me give you 2 examples to try. So try these 2, and then we'll do these together in class. Call this example C. In the example C, they give you 1 squared plus 2 squared plus 3 squared ... plus 9 squared. And for D, they give you 1 plus 1/2 plus 1/4 plus 1/8 ... and then 1 over 2 to the n minus 1. So starting with the first one, notice your end point and your beginning point. So this is obviously a 9. This is an I equal to 1. And your formula for this should be I squared, because that's basically what's happening. For this formula, it ends in nth minus 1, so that means that I don't know the end, but I do know that we could start with I is 1 of the formula, where I have 1 over 2 to the I minus 1. And that's the gist of this chapter. That's pretty much all the examples, a bunch of tries in between. So take your time with this. Little tedious in some cases, but you can formulate this, and I even showed you how to use Excel for that. You can use a TI-83 calculator, but you can't use it on a test or quiz technically. So, but I'm going to show you real quick so you can see that you can actually use the TI-83D4 calculator. Let me pull that up, and I'll share that with you. And so I'm going to do a real easy example with you, and you can just play with the calculator at your will. So if you go into, let me see, I think it's math. Maybe it's not math. Oh, here, math, summation. See, you can actually put in your values. So let's say hypothetically I have an example, and let's say I want to do a 5 here. Did I freeze it? Oh, I froze it. Sorry. Let's go back to math. I believe it was a 0. Okay, and so I want to make sure that I click in this box. What is the matter with this thing? Oh, there you go. So this would be your I. This would be, let's say hypothetically, since everything is 4. Okay, so let's start with 4, and I'm sorry, this would be the 1. And let's do example, I believe it was example 1 that had, let me go back to the, give me 1 second, pull it up, I'll give you the equation. So you can, the reason I'm showing you this is because this gets tedious, and if you're not using Excel, at least use the calculator to check your answers as you're doing the homework. Now, don't become dependent on this, because this will end up being a problem if you can't pull up your, information. So let's say hypothetically I have I squared. Oh, Let's put an I in here. Okay, so it doesn't like this. Let's call it X, whatever. Okay, let me click on this. Click X. And let's raise that to the second power, and then let's go with plus. Let's go with +2. I'll make one up. So this isn't anything you have in your homework. And I do that, it automatically does the equation for you. So 1 squared plus 2, 3 squared plus 2. All right, so I might want to, you may want to change this so that it matches as an X. Let me see if I can get it to move up. Yeah, it's going to be a problem, so let's see here. But in any case, change it to an X and it'll do the math for you. Just like if I had, this is x squared plus 2. All right, so I'm going to have 1, 2, 3, 4. And this is equal to that number squared plus 2. All right, and so you shouldn't have a decimal, which is why I already know that it's not adding correctly. So if you do the math for that one, you should have 38 as your answer. All right, and the calculator is the same thing. It's only you have to change that to an X and it'll actually work. All right.